Okay, so this is the third video segment for homework number 5, and I'm going to be doing this problem. Okay, so that we have more room, let me go ahead and copy this down below. Get rid of these. Okay, so where are we here? So we have y equal to 2 tangent of 3 pi x. Okay, first of all, as far as this 2 goes, it's stretching in the vertical direction. So I'm not going to even bother it right now. Stretching in y direction. So for now, I'm going to ignore it as if I was doing this. Tangent of 3 pi x. Ignore for now. Ignore for now. When you look at this is what we call k, and k is equal to 3 pi. So the period of this function is pi over 3 pi, which is 1/3. The period of this function is 1/3. So what that means is that I need to graph this in an interval of length 1/3. Now the way tangent, if we temporarily ignore that 3 pi, the way tangent was done in the book, although the period was pi, this is tangent of x, not tangent of 3 pi. Tangent of x was pi. It was plotted between minus pi over 2 and pi over 2. So we do exactly the same thing here because we're dealing with tangent, and this is the period. We're going to go between 1/6 and minus 1/6. So 1/6 is going to be right here, for example, and minus 1/6 is going to be right there. The only reason I did it like that is that tangent in the book is done from minus pi over 2 to pi over 2, which means the period is pi. Here the period is 1/3, half of it this way, half of it that way. This is the x-axis, this is the y-axis. And we know exactly how tangent looked like. Tangent looked like this. These were the asymptotes. Remember, these were the asymptotes? This is not very good drawing. So let me erase this piece. Let me try to draw it again. So this is tangent, looks like that. For example, it's a good idea to take always one point. Maybe if I took this point, the point in the middle, which is incidentally 1 over 12, okay? And we plugged it in there. We plugged it in that 3 pi x. It's going to be tangent of 3 pi times 1 over 12. So that's pi over 4. So this height is 1. This height is 1, okay? And obviously, if you go to minus 1 over 12, halfway point, this height is going to be minus 1. Now, because we have a factor of 2 here, we're going to stretch everything by a factor of 2. So let me draw that as the red curve, the desired curve. So this height of 1 is going to go to height of 2. This height of minus 1 is going to go to minus 2. This is 0, doesn't go anywhere. So the graph of the thing that we want is going to go like this. So this is the graph of 2 times tangent of 3 pi x. Okay, let's do the next one. The next one is right there. Y equal to 2 tangent of pi over 2x. Let's go do it here. Another page. Okay, that was fine. So my next problem is going to be y equal to, let me see, 2 tangent of pi over 2x. Once again, temporarily ignore this. Temporarily ignore it. And this is the value of k. K is equal to pi over 2. That means period is equal to pi over k, which means pi over 1 over pi over 2, and that is 2. So the period is 2. In compliance with what we talked about a minute ago, we're going to plot this thing between +1 and -1. That gives you a period of 2. This is a +1, and there's a -1. And if we ignore the 2 in the front, this 2 in the front, we fit the tangent in this interval like that. Tangent goes like this, yeah. And if you want one value, for example, at a halfway point, that doesn't surprise you. If you take the halfway point, which is 1/2, and you plug it in there, you get 1/4, and this height is 1, and this is -1/2, and this height is -1. Okay, so now we want to take into account this 2. All we do is we stretch everything in the vertical direction by a factor of 2. So this one goes to height of 2. This height of 1 goes to height of 2. This height of -1 goes to height of -2. This is 0, doesn't go anywhere. So the graph is like that. Please, you have to realize that this red curve is actually approaching the asymptote, although I'm not drawing it like that. But as you go up, 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 this is getting closer and closer, closer, and down, 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 closer to those things. So we just did this problem. What's the next one that I want to do? The next one is going to be number 47. Let me erase these things. Let me see. Can I erase these things? Okay, let me erase these. Erase this and erase that. Okay, let's go to number 47. Now these are getting a little bit involved because let me just write down number 47 for you. It looks like this. 5 secant of 3x minus pi over 2. The first thing that you want to do is to identify the k. K here, it would be helpful if you wrote it like that, 5 secant of 3 times x minus pi over 6. The only reason I wrote it like that, because it gives you the shift. So if we can plot, and we should be able to do, if we're able to plot y equal to secant of 3x, which means we have ignored the pi over 6 and we ignored the 5. If we can plot this, we should be able to do it. Then we shift it to the right by pi over 6, and then we stretch in the vertical direction by a factor of 5. Okay, so let's go ahead and do this. K equal to 3. So period is equal to pi over k, which is pi over 3. Okay, and our secant, in compliance with what's in the book, is drawn between 0 and the period, pi over 3. Okay, so let's see now. Let me try. We may have to do this thing several times because, in fact, graphing is always, unless you're doing it with your calculator, is always an iterative process. So we go from 0 to right there to pi over 3. Okay, this is the period. Now secant, if you go to, let me remind you what this thing is. This is 1 over cosine of 3x. So every time cosine of 3x becomes 0, we have a problem. For example, when 3x, just look at it, when 3x is equal to, for example, let me see, when 3x is pi over 2, which incidentally, it means that x is pi over 6, because this is the x-axis, okay? this is the x-axis, we have a problem. So we're going to have a problem right here. This is the middle point, no problem. We're going to have a halfway point there, halfway point there. Okay. So let's make sure that we know this thing. We're dealing with secant. So right. So let me see now. Problem where this is pi over 2, x is pi over 6. What would pi over 6 mean? Pi over 6 would be at this location. Let me see for a second. When 3x is pi over 2, that means we are dealing with cosine of pi over 2, that is 0, and x is pi over 6. So something that I don't like here. You know, I made a mistake. The problem, this would not come out to be what I was expecting. The reason I made the mistake there, please make sure that we go here and fix this thing. Period is 2 pi over 3. So this is 2 pi over 3. This is pi over 3. And pi over 6 is right here, and it's our trouble point because there is a vertical asymptote there, and there's a vertical asymptote here. Okay. And we have done this before, so secant is going to look like that. And it's going to go like this. This red one is secant of 3x. Okay? Now, we have to shift this thing to the right by pi over 6. So remember, this length is pi over 6. Okay, so that's going to be tough to do it, but we'll try. So this vertical line, this vertical asymptote is going to go right there. The left vertical asymptote, red vertical asymptote goes here. The right one, this right vertical asymptote, this one is going to go to there. Okay? This point is going to go here. And the green one is the shifting of that fellow by pi over 6. You can see that. Okay? And I made a mistake in this fellow. Let me see for a second. Pi over 6. No, I guess it was okay. This was okay. Okay. Right. No, it was fine. So this red curve here, you see that? This red curve is going to get shifted by pi over 6 like that. Okay. And finally, there is the shifting of this red piece over there. So this point, incidentally, is pi over 3 plus pi over 6, which incidentally it is pi over 2, by the way. Is it pi over 2? Let me see. Oh, sorry. There's a 2 pi over 3 plus that. So 5 pi over 6. This point is 5 pi over 6. So the green one is secant of 3x minus pi over 6. And finally, we want to multiply everything by a factor of 5. Now that's going to be tough because so for example, these heights which are 1, use a different color. These heights which are 1, now we're going to go to a factor of 5 up here, up there. This one is going to go to 5 somewhere up there. Oops, like that. This height is 5. And this fellow, which was also 1, is going to go down by a factor of 5. Now I don't have enough room to do this here, but yep, it's going to go like this. So this was 1 minus 1. It's going to go to minus 5. Let me zoom out here. Right. So you can see it's just like the secant, but shifted, fitted in an interval. Let me move these asymptotes up. It's just like the graph of secant, except that it shifted to the right and it's stretched in the vertical direction, and the interval, of course, has changed. Okay. Now, the last problem that we're going to do is going to be this number 49. It's going to be uglier. Let me get rid of all this stuff. There is no fast way of doing these things. You have to be patient, and you have to rely on what you already learned or what you made to recall. Okay, so let's see now. 2/3 of x minus pi over 6. So let me write it here. Y equal to tangent of 2/3 of x minus pi over 6. Okay, so first thing I'm going to do is rewrite this thing as tangent of, I'm going to factor the 2/3. So it's going to be x minus pi. Let me see now, when I multiply, so let me see now, 1/6 divided by 2/3. So this is 3 over, this is going to be minus 4 pi, if I'm not mistaken. Is that right? No, no, no. 1/6 divided by 2/3. So that's going to give 3 over 12. Okay, 3 over, so it's going to pi over 4, not 4 pi. Okay, so let's get to this. All right, good. If you multiply 2/3 by pi over 4, you get exactly pi over 6. Okay, so let's see. Where is this? Draw. Let's get to this. Okay, let me change the color of that. All right, so here is my k value. K is 2/3. This is the shift. B equal to pi over 4, shifting to the right. Okay. So first of all, the period is equal to pi over k. So it's going to be pi over 2/3, and this is going to be 3 pi over 2. And as I said, in compliance with how it's done in the book, the tangent, we're going to go between minus half of this. So it's going to go from minus 3 pi over 4 to 3 pi over 4. That's how they're drawing tangent in the book. So let's see now, this is the vertical asymptote at these two locations. Very good. And tangent goes like this, right? Tangent goes like that. Okay. So now we have to shift everything by a factor of, by amount pi over 4. Now let's think about it for a second. This is 3 pi over 4. This whole thing is 3 pi over 4 from here to here. So if you divide it into 3 pieces, you get the amount pi over 4. So all you have to do is to shift this whole thing. Let me use a different color here. Okay. So pi over 4, we shift it like that. Let's say this is pi over 4. And we shift this thing by pi over 4, like so. And this is going to go here. So let's see now. The curve goes like this. And that takes care of the problem. See that? This horizontal distance shifting between the black and the green is pi over 4. So the final answer, tangent of 2/3 x minus pi over 4, which is incidentally the same as this, is the orange one that I've done for you. Okay? Now there's two more problems that are left, and let's see now how much time we've got here. I think I can do it in, I'll do it in the fourth video segment. Okay? We stop this.